Okay, we're working on applying the model here. We have the three situations and we're trying to figure out whether CVPM or CAPM apply. So in the first one, we know that we're changing speed because we're starting at rest and ending not at rest. So for one, I'm going to say CAPM, assuming that A is constant. So we haven't really been given that, but certainly it's a better model of the situation than CVPM would be, because the velocity is definitely not constant. For 2, we have Dune Buggy traveling for 20 seconds at this constant speed. So we're in CVPM because there's no speed change. The third one, we're braking, which means our car is changing velocity. We're going from 8.5 meters per second to 0. And again, we're going to assume that A is constant. But in both of these, V is changing. Alright, so we're going to draw 3 graphs to illustrate the situation for 1 and 3. So here are our blank axes. In the first one, we're starting from rest, which means that my VI is 0. And it's going to reach a speed of 8.5 meters per second in 20 seconds. I'll assume arbitrarily that that's in the positive direction. We're not really given that, but it doesn't really change anything one way or the other, except for our signs. So we're going to go from 0 to 8.5 meters per second, and that's going to be in 20 seconds. Okay, this means that our position is going to start with a slope of 0, so it's going to be flat. I'll just start here. I could start wherever I want. So it's going to start with a flat tangent, and then the slope is going to get more and more positive. So we're going to start at that tangent and then slope up. The acceleration graph is the slope of the position graph. So that slope is positive and constant, so my acceleration graph will be positive and constant. Alright, for the third one, our initial velocity is 8.5 meters per second. I'll assume that that's positive again, just arbitrarily. You might have the mirror image of all 3 of my graphs if you don't make that decision. The car is going to come to a stop, so VF is going to be 0. 20 seconds down, and if it's CAPM, that's going to be linear. So our acceleration graph is the slope of that. That is a constant negative slope. So we'll have a constant negative acceleration. And my position graph, I can start wherever I want. It's pretty arbitrary, so I'll start up here. I'll start here. I should have a positive slope that's very big, and then at the end I'll have a slope of 0. So my positive slope gets smaller and smaller. So there's a positive slope that's big, and then gets smaller and smaller, and at the end I have a flat tangent.